It's another time with BakoMaths, and today's lesson we'll be looking at how to rationalize the denominator of a set. And if you are not subscribed to this channel, kindly subscribe and hit on the notification bell so that when a new video is being published, you are going to be the very first person to be notified. Now let's get started. Set rationalization. The main idea of rationalizing the denominator of a set is that in mathematics, it is considered improper to leave a set in the denominator of a fraction. Now, this is what we are saying. If we have a fraction as a out of square root of b, now this is a fraction. And this fraction, we can see that the denominator here is a set. And because the denominator here is a set, it is making it improper to leave it as that, which means we have to do something about it. Doing something about it means that we are trying to reduce it to its lowest form. Now, the process of reducing it or simplifying it to its lowest form is what we call as set rationalization. Now, we can rationalize both numerator and denominator of a set, but this video is focusing on rationalizing the denominator of a set. Now, this is what happens. So this is an instance like this. Now, in set rationalization, where we are focusing on the denominator of a set, it has two types. Now, since we are dealing with type 1, then let's write here as type 1. So it means that this video is going to take into consideration both type 1 and type 2 in rationalizing the denominator of a set. So type 1, this is what we have. Now, in type 1, we are saying that if we have a set of this form, if you have a fraction of this form, a out of square root of b, and we are saying that this is improper for us to leave it like that, then it means you have to rationalize. Now, the process of rationalizing is as follows. Let's be attentive and take notes. Now, here we write the fraction given to us as a out of square root of b, and to rationalize this, we have to multiply both numerator and denominator of this fraction by the denominator of the fraction. So we are going to multiply both numerator and denominator by the denominator of this fraction, that is square root of b, which implies that we should multiply here by square root of b and also multiply here by square root of b. So this is what we mean by rationalizing the denominator of a set. Once you're able to do this, the next step is to multiply. So when we multiply a and square root of b, then we have a square root of b divided by, when we multiply square root of b and square root of b, then we should have square root of b all squared. And at the end, we can see that this square takes away the square root. So we are left with a square root of b divided by b. And when we rationalize a out of square root of b, then our answer is a out of square root of a would be out of b. Now, after rationalizing, you can see that the original fraction, of which a denominator is a set, is now a rational number. So it means that when we rationalize, the denominator does not become a set again, because that is not what we want. We want the denominator to be a rational number. So that is the clear difference. Because it is considered improper to leave the denominator of a fraction as a set, then we have to rationalize so that it doesn't become a set anymore, but rather a rational number. And b is not a set but a rational number. So this is what we mean by set rationalization, emphasizing on rationalizing the denominator of a set. Now, if this is clear, then let's take practical examples on instances like this, that is, we focusing on type 1 of rationalizing the denominator of a set. So example 1, and says that we rationalize 3 out of square root of 5. Now we have to solve this, and our question is 3 out of square root of 5. Now, in this fraction, we can see that the denominator here is a set, and because it is considered improper to leave it as such, then we need to rationalize. So rationalizing means that you have to equate it to the fraction given to us itself. And the next step here is that we have to multiply the denominator of this fraction by both the numerator and denominator of the fraction itself. So that is multiplied by square root of 5 divided by the square root of 5. So that is said rationalization. Once we are able to do this, the next step is about multiplication, and we are good to go. So it's equal to 3 square root of 5 divided by, now square root of 5 multiplies square root of 5, we all know to be square root of 25, which is equal to 3 square root of 5, and we know square root of 25 to be the same thing as 5. So when we rationalize 3 out of square root of 5, then our final answer becomes 3 square root of 5 divided by 5. And you can see that in the original fraction, the denominator happens to be a set, that is square root of 5. But after rationalization, the denominator now is 5, which is a rational number. And that is the main purpose for rationalizing the denominator of a set. Now, having understood this, let's move to example 2. Example 2 is saying that we should simplify 8 square root of 2 divided by 2 square root of 3. Now, what we are going to do here is to write our question, and it says 8 square root of 2 divided by 2 square root of 3. And with this, we have to write it 8 square root of 2 divided by 2 square root of 3. And since the denominator here is a set, then means that we have to rationalize. Rationalizing means that we are going to multiply both numerator and denominator of the fraction by the denominator of the original fraction given to us. And the denominator here is 2 square root of 3. So multiply by 2 square root of 3. Numerator part divided by 2 square root of 3. And that is all about said rationalization. The next step is for us to multiply. So 8 multiplies 2, we have 16 square root of, now 2 multiplies 3, that is 6, divided by, now 2 multiplies 2, we have 4 square root of, now 3 multiplies 3, we have 9. So this can be further reduced, and we have 16 square root of 6 divided by 2, and we know square root of 9 to be the same thing as 3. So we multiply here by 3. Now the next step here, we can see that we can multiply the denominator, that is 16 square root of 6 divided by 6. And so it means there is a mistake here, we have to rectify. So this place is 4 and it's not 2. It means you have to clean this and write 4 here. So which implies that 4 multiplies 3, we get 12. So it should be 12 here. Absolutely nice. So you have 12 here. And we can see that when we reduce 16 and 12 to the simplest form, then we have 4 out of 3 square root of 6. And that's beautiful. So when we rationalize 8 square root of 2 divided by 2 square root of 3, then our answer now is 4 square root of 6 divided by 3. And this is rationalization of set. That is emphasizing on the denominator part. And at this instance, we can see that the denominator here is not a set, but rather a rational number. Now let's take the last example on type 1. So that's the last example on type 1, and it says you rationalize 1 out of square root of 2 plus 1 out of 2 plus 1 out of 2 square root of 2. Now at this point, you can pause the video and try your hands on this question. So we have our solution as, now we want to rationalize this. So you see there is a fraction, and this fraction there is a set, and some part there's no set, and some part there is a set. So you are going to focus on the part of there is a set, and we are going to rationalize the part that there's no set. We are not going to do it anything, we maintain it as such, and we break it down to find a solution. So we have 1 out of square root of 2 here, And since this is a set, I mean focusing on the fact that the denominator is a set, then we need to rationalize. So rationalizing gives square root of 2 here, then square root of 2 there. So you put it in one bracket and we come here. So 1 out of 2, there is no set at the denominator, so we maintain it, and plus. Now at this point there is a denominator here, and the denominator here, it is a set, so we need to rationalize. So 1 out of 2 square root of 2 multiplied by 2 square root of 2 divided by 2 square root of 2. So simply we can also put this in brackets, and that becomes nice as that. Now the next step here is to multiply. Once you are done with the rationalization, it's just to multiply. So 1 multiply square root of 2, then we are going to have your square root of 2. And you know, square root of 2 multiply square root of 2, since they are like sets, then we are going to have 2 here. And we have plus 1 out of 2 plus, so you know, 1 multiplies 2, we have 2 square root of 2 here, and 2 multiplies 2, we have 4. We can see here that square root of 2 multiplies square root of 2, then definitely we are going to have 2, so multiplied by 2 here. Now the next step here, we can see that we can reduce this to, we maintain 2, that is square root of 2 divided by 2 plus 1 out of 2 plus 2 square root of 2, and here 4 multiplies 2, it gives us 8. Now we can see that at the denominator part, there is no set here, and that is the main focus for we rationalizing a set. Now what we have to do here is to find LCM and also simplify this. Now before, we can see that 2 goes into itself 1 and goes into 8 4 times, so you can also break it down as such. Now we have square root of 2 out of 2 plus 1 out of 2, and then plus 1, that is square root of 2 on 4, and we can equally find the LCM here, so divided by 4. Now 4 goes into 2, we know we are left with 2, so 2 multiplies 2 square root of 2, and 2 goes into 4, 2. Now 2 multiplies 1, you have 2, plus 4 goes into 4, 1, and we have square root of 2 here. Now having done that, we can see that there are like sets here, so that is 2 root 2 plus square root of 2, then definitely we are going to group them and add. So 2 square root of 2 plus square root of 2 plus 2, all divided by 4. Now the next step here is that we are going to add the like sets, and when we add, we are going to have 3 square root of 2 plus 2, all divided by 4, and we have been able to rationalize this. So this, the simplification or the rationalization of the question, 1 out of square root of 2 plus 1 out of 2 plus 1 out of 2 square root of 2, and this becomes simple. Now this is type 1 and how to solve questions related. Now let's move to type 2 and look at instances involving type 2. Now type 2 is saying that, so we are type 2 now, and saying that if we have a fraction and the fraction, it has a denominator to be of set of this form, so a out of b plus square root of c. Now here we can see that the denominator here consists of a rational number being added to a set. So how do you solve instances like this? Unlike the type 1, it was only a fraction where the denominator happens to be a set only. Now in this case, there is a rational number being added to a set. So how then do we solve questions like this? So in questions like this, then it means that we are still going to rationalize by multiplying the denominator by both numerator and denominator. But in this instance, there is a caution. Now let's look at it. So we have a out of b plus square root of c. Now with the process of rationalization, we all know that we are going to multiply this fraction by the denominator of it. So that the denominator, this one. But in this case, Since they are being added, we have to change the sign to its opposite sign. That is, we finding the conjugate of the denominator. Now changing the fraction in between the denominator here, then we are going to have b minus square root of c divided by b minus square root of c. So first we rationalize. Rationalization means that multiplying the fraction by the denominator of the fraction. Now that is one way of rationalize. The next step is that we have to find the conjugate. Find the conjugate means that we are going to change the sign in between the denominator, so to its opposite sign. Now its opposite sign here will be minus. So this is the process of rationalizing questions of this form. That is what we term as type 2. Now once we are able to do this, then we continue with our normal multiplication. Now having understood this, then let's solve questions related to type 2. So type 2 we have here as rationalize square root of 5 divided by square root of 6 plus square root of 2. Now it means we have our solution as square root of 5 divided by square root of 6 plus square root of 2. Now since this denominator involve the addition of two sets, we are looking at two different terms here, then we have to find the conjugate as we rationalize along. So multiply here by square root of 6, and we are going to change the sign in between these two sets here to its opposite sign. That becomes minus square root of 2, and the next step here is to divide by square root of 6 and minus square root of 2. Once we're done with this, then we are done rationalizing this set. So the next step is to multiply square root of 5 by square root of 6 minus square root of 2 divided by square root of 6 multiplied by square root of 6 minus square root of 2, and then we have plus square root of 2 being multiplied by square root of 6 minus square root of 2. Now once this is done, then we continue with the multiplication. So here we can see that square root of 5 by square root of 5, square root of 5 times square root of 6 gives us square root of 30 at the numerator, and minus square root of 5 square root of 2 multiplied gives us square root of 10. So you have it as that, divided by, now square root of 6 times square root of 6, because they are like sets, you just take the square root sign off and you are left with 6 minus, so square root of 6 times square root of 2, they are not like sets, so we multiply the set and you have square root of 12. Now the next one we have plus square root of 2 square root of 6, we have square root of 12 here, and minus, so square root of 2 square root of 2, because they are like sets, then we are going to have here as 2. Now there's one thing you have to note about set rationalization when it comes to type 2. The moment we rationalize and we find a conjugate along and we multiply, there is this common thing that we can see. We can see that at the denominator there is minus square root of 2 and plus square root of 12. That is minus square root of 12 plus square root of 12. And once it involves type 2 like this, they are definitely going to cancel. So in instances like this, there must be a cancellation at the denominator, and that's what we have to take note of. Now once we cancel, then we can continue with our solution. So here we can see that there is square root of 30 and minus square root of 10, and what is left is 6 minus 12 is 4. So at this point we can see that when we rationalize square root of 5 divided by square root of 6 plus square root of 2, then our final answer is square root of 30 minus 1, that is square root of 10, all divided by 4, and that is rationalization of sets, emphasizing on the denominator. Now let's move to the next example in instances like this. So example 2 here, it says that we should simplify square root of 3 minus square root of 2 all divided by square root of 3 plus square root of 2. Now in solving this, then we are going to have our square root of 3 here minus square root of 2 divided by square root of 3 plus square root of 2. Now in rationalizing, we have to find the conjugate. Conjugate means that we are going to change the sign in between the two terms here. So multiplied by square root of 3, that's we rationalizing, and find the conjugate divided by square root of 3 minus square root of 2. Once this is done, the next step is to multiply. So we multiply square root of 3 by square root of 3 minus square root of 2, and we have here as minus square root of 2 multiplied by square root of 3 minus the square root of 2, all divided by the square root of 3 multiplied by the square root of 3 minus the square root of 2, and we have plus square root of 2 multiplied by the square root of 3 minus the square root of 2. Now once we have this, we can see that we are going to multiply both numerator and denominator. So considering the numerator, then we have here square root of 3 square root of 3, because they are like sets here, then we are going to have 3 here minus, so they are not like sets, that's really considering square root of 3 and square root of 2 being multiplied, we have square root of 6 beautifully. Now let's write it well. So square root of 6 here, and square root of 2 square root of 3 gives us square root of 6, and then plus, so that is minus square root of 2 minus square root of 2 gives us, since they're like sets, so we have 2 here, all divided by square root of 3 square root of 3 gives us 3 here, and we can see that square root of 3 square root of 6 gives us, square root of 2 gives us square root of 6 plus, so you have square root of 6 here and minus 2. Now what we can see is that there is a cancellation. That is the beautiful thing about third rationalization, where you have two terms here. So minus square root of 6 takes away positive square root of 6, and our solution now becomes, that is equal to 3. Now minus square root of 6 minus square root of 6, because they are like sets and then they are adding, then we have 2 square root of 6 here, and we have plus 2 divided by 3 minus 2. And the next step here, we can see that we are going to have 3 plus 2 gives us 5, so we have 5 here, and you have 2 square root of 6 all divided by 1, and at the end we should have 5 minus 2 square root of 6, and this becomes our solution to square root of 3 minus 2 square root, then square root of 3 plus square root of 2, and we have our solution as such. Now let's move to the last example for today's video, that is type 2 on rationalizing the denominator of a set. So we have our last example here, and saying that we should rationalize 2 plus square root of 3 divided by 4 minus square root of 3. So what we can do here is that we rationalize as we find the conjugate along. So that is 2 plus square root of 3 divided by 4 minus square root of 3 multiplied by 4 plus square root of 3 divided by 4 plus square root of 3. Once this is done, then 2 multiplies the whole of 4 plus square root of 3, and square root of 3 multiplies 4 plus square root of 3, all divided by 4 multiplied by 4 plus square root of 3. Then we have minus square root of 3 multiplying 4 plus square root of 3. Now once we have this, we continue with our multiplication. So 2 multiplies 4, we have 8, and plus 2 square root of 3 here, and plus, so we have 4 square root of 3. The next one becomes, since they are like sets, then we should have 3 here, divided by 4 times 4 gives us 16, and we have plus 4 square root of 3, and minus 4 square root of 3, and we have 3 here. Since they are like sets and they are multiplying, we have 3 here. So the next step here is to continue with the simplification, and here you can see that there is a like set here, that is 2 square root of 3 plus 4 square root of 3. So kind of grouping like terms. So we have 8 plus 3, then we have, so we add these two, then we should have 6 square root of 3, then divided by, so what do we see? We can see that this takes away that because it's plus and minus, so they go away, and we are left with 16 minus 3, and we can see that 8 plus 3 gives us 11 plus 6 square root of 3, and at this point 16 minus 3 gives us 13. So we can further write it as 11 on 13 plus 6 on 13 root 3. Good. So when we simplify or rationalize 2 plus square root of 3 divided by 4 minus square root of 3, then our solution should be of this form. So this is all about rationalizing the denominator of a set, and I believe you enjoyed this video, and we end to this video here. So thanks for watching. Kindly like, you comment, subscribe and share. Remember that this is BakoMaths, thinking beyond infinity.